All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be taking a short detour, which we kind of already took yesterday, I guess. But yeah, anyways, today we're going to be taking a short detour from what we were doing, which was, I believe, polars and working on the content pipeline and probably a couple of other things. But yeah, today we're taking a short detour, which is now, I think, the third time that I'm saying that. We're going to be diving into ESP32 Rust again. More specifically, today I want to focus on monitoring serial data coming in from the ESP32, and I want to see if I can pipe that into some other program. So I spent most of yesterday, after yesterday's stream, I spent most of the time, even up until like today's stream, up until the point where I started streaming, I was still continuing doing research on it because I was. Oh yeah, I didn't mention what exactly I spent my time on. I spent most of yesterday after yesterday's stream. I spent most of my time doing research on serial communication, serial data coming into the PC, and well, usually I end up getting kind of curious about how things work on the lower level, and so I start doing research on various moving parts that are involved. In this case, the various moving parts involved that at least that I did research on are UART and USB and named pipes. That's another one, which I'm glad that I did research on that. I'll talk about that in a little bit. I'm still very new to it, and I still need to I need to actually do it practically. So far, I've only like read up on it. I haven't really used it practically, but once I get around to using it practically, I feel like I'm going to be using it for a lot more than just what do you call it? A lot more than just monitoring serial data. I was also doing research on Scope TUI because I read up on Scope TUI after yesterday's stream. I don't remember how much of it I discovered during the stream, but like after the stream, I definitely read up on it more. And I got GitHub Copilot to analyze the entire Scope TUI repo and explain how file source works, because one of the sources that you can use to give input to Scope TUI is a file source. So it can either read from a file or read from a named pipe. I believe it can also read from a file. Yeah, I believe it can read from a file as well. But yeah, it's called a file source either way, and it supports named pipes. So you can pipe data into this. But this got me curious about like what type of data is it expecting? And that's why I asked GitHub Copilot to analyze the repo and explain to me exactly what kind of data it's expecting, in what format it's expecting. And it turns out Scope TUI is very, at least initially, what it was designed in mind with, I guess, is audio. So it's very heavily focused on reading audio data. So even when it's using the file source, it is expecting data to be 16 16-bit signed, I guess, little endian PCM format. And based on the sample rate that you specify, you're going to have to provide it with a set number of samples that it's expecting per second, and then it's going to plot that. I still have to test out that theory. I haven't managed to do that yet. I guess what I'll do is just generate a simple sine wave and split it up across, I don't know, 48,000 samples. And also, there's also the fact that it's expecting. I could probably change that, but yeah, it's expecting two channel data, so it's expecting stereo data, stereo audio. So I need to keep all of this in mind when I'm trying to use Scope TUI. If I can manage to set up, if I can manage to give Scope TUI the appropriate parameters to use it as a serial monitor, then I could probably plot the data. I have to explore Scope TUI more for that, but like before that, I wanted to understand the concept of named pipes, and this is a very interesting concept because I've come across this concept before, but I never actually dove deep into it. All I know is that it can be used for interprocess communication or IPC, and that was about it. I didn't really look into how to set it up, what are the specifics around it, which applications can use it, how do applications use it. I never looked into any of that. And yesterday I did that. I looked into it specifically on the Linux side. I haven't looked into it on the Windows side. There's a tool called MKFIFO, which you can use to hold on. I I believe I have TLDR installed here. Yeah, I think so. I believe I have TLDR installed here. TLDR MK FIFO. So these are some examples of how you can use MK FIFO. There's also the man page, of course. Give me a second, or well, give uh, my SSH a second because it's taking some time. But yeah, you can use this tool to create named pipes, and these named pipes will persist on your within your file system. I don't know if they persist reboots. I'll have to test that out myself. But they do remain active until you yourself close them. And while they are there, you can essentially use them as a buffer to hold data. So you can pipe something from one program, you can pipe something into this named pipe, and then from another program you can read from this named pipe. I guess the advantage here is that you don't have to directly pipe the output of one program into the input of another program. You can just pipe it into a named pipe, and then in the other shell, you can you can have it read. You can have another program read from that named pipe, and that's essentially what I want to do in this case. The the idea here is that I'm going to flash the program onto the ESP32 after compilation. And actually, speaking of which, oh yeah, we're done. We're done with the lag. I don't know, for some reason. I think it's my router. I think it's my router because it seems like my internet connection speed also seems to be getting affected. I don't know if it's just my router kind of, slowly giving up. Over time, routers do kind of degrade in, well, they how do I say this? Over time, as the router as the router's lifetime goes on, its quality kind of degrades slowly, and usually at that point you probably want to change the router. I'm hoping that this lasts longer. I do have a router that I can test out. I really don't want to mess with any of the SIM card stuff right now, though. That's why I don't want to remove the SIM card from this router because things are working right now. Let's just let them keep working. If it becomes like completely unbearable and I'm not able to stream, I'm not able to use the internet at all, then yeah, sure, I can. Oh, then yeah, sure, I can change the router. Anyways, enough about the router. Um, so the idea here is that I write a Rust program for the ESP32, and the only thing that this program does is it prints out data um, to the console, and I'm hoping that that shows up as serial data. So, no, sorry. I hope that that counts as serial data. So I'm hoping that that shows up in um, something like uh, TTY. No, is it USB? Oh God, it's stuck again. Okay, hold on. I can do it here. Okay, TTY USB, or is it USB TTY? Hmm. Hold on. Slash dev. Why is that not showing anything? Is it TTY USB or USB TTY? I'm not sure. How do I check that? I'm gonna have to flash another program on there, which I don't want to do. What am I missing here? It's not serial. Is it under dev? Wait, okay. Uh, let's do that. Yeah, there it is. Like, why was it not showing up? Okay, let's do this and slash dev rg tty. Okay, give it a second. Okay, right. So we are looking at TTY USB. Why was this not like auto completing for me? Oh, because there were multiple. Now I forgot why I was. Oh yeah, so the reason I was mentioning this was because what I'm hoping is that it's gonna write the data to this. It's gonna write the data to TTY USB 0, but I'm not going to be reading the data directly from TTY USB 0. I'm going to be reading it from, I'm going to be using ESP flash monitor. So ESP flash monitor, and then I have to pass it the path for TTY USB. Oh, give me a second. I just remembered that I didn't open up my stream chat on my phone. Oh, another little issue that I ran into is that when I went to look at the documentation for Rust, no STD, ESP32 stuff, apparently the documentation's kind of broken right now because it was so like it in the documentation it mentioned right at like the introduction page. It mentioned that this information is out of date. So go to so and so repo and go to so and so branch and get the information from there. I went there and I was specifically, let me show you. So if you look up in the Yahtzee window, and I'm glad that I did this because I wouldn't have thought about going back to one of the previous commits to find this information. I'm glad that I did this. A while back, I had cloned the NoSTD training repo, and I don't think I really made any changes directly to the repo. At least I hope I didn't. Um, hold on. Let me go into, okay, NoSTD training. Let's open up Git UI. So this is, these are the commits, and I cloned this ever since I cloned it. Fortunately, I didn't pull any new information. So I'm still on one of the older commits, and yeah, I haven't made any changes to this repo, fortunately. So, and also fortunately, I not downloaded, I cloned. Well, technically downloaded as well, but fortunately, I also cloned this repo, and that's why I had access to this information. Because now, if you go to this repo in both the master branch and in the feat slash what do you call it? Something something. I don't know. Feat doesn't feature. Feat slash I forgot what branch they're expecting you to hold on. I don't want to switch to that branch right now. I want to remain in currently I believe I'm in, I don't remember. Anyways, so fortunately I had this with me, and so I opened up my copy of the repo and looked at the last commit that was there. And so I had this idea that, okay, if I go to GitHub, where things currently are a mess in the repo, and I jump back to one of those commits, the good news is that GitHub does give you that option to just jump back to that commit, and then you can then you can see the repo in that state. So that's why I have access to these examples right now. And I need to make a post about this today as well, because I have no idea when that thing is going to be fixed. And as it is, the ESP32 Rust, no STD specifically, documentation tends to be all over the place because it's constantly like developing and evolving and stuff, which is fine. But then for somebody like me who's a beginner but not a complete beginner, I have access. I have not access. I have experience with at the very least, building or creating the project using using ESP generates TUI, and also flashing a simple like Blinky program onto the ESP32. For someone like me with with relatively beginner knowledge but still some knowledge, it might be fine, right? It's still like the information is still spread all over the place. There were situations where I had to figure out things on my own, but things are still relatively easier for someone like me, who again, still very much a beginner but not a complete beginner in in this. For someone like me, it might be a little bit easier, but somebody who's coming in like brand new, they're going to be completely lost. And when you are completely brand new, and on top of that, you're looking at broken documentation, that is just, it's a horrible time. It's gonna chase people away. So what I'm gonna do is I'm gonna post about this. Initially, I was gonna be like, okay, let me create my own set of examples to help people out. The issue is I could do Blinky, I could do button interrupt as well, maybe. I could do button, as in I'm reading out the names in this repo on the left side, which I'm just realizing now that you guys are probably not able to see it that well because I've made the browser window small. So these are the examples that I'm talking about. I can do Blinky, I can do button interrupt. DFMT, I think it's more to demonstrate the tool itself, tool slash library, whatever it is. DMA, I don't know. I'll have to see how that is being demonstrated. I can also demonstrate hello world. I think that's printing hello world. Yeah, I believe that's printing hello world. And I can also, oh, give me a second. Yeah, I can also um, demonstrate panic, because panic is just to, well, demonstrate how the program panics, because the program panicking on the computer, a Rust binary panicking on the computer is different from a Rust binary panicking on an ESP32. Because with an ESP32, there's multiple differences. One very big difference is that there's nothing to return from the program. So like you don't ever want the program to like really return. There's nothing to do. There's like nothing after that. So the program has to keep executing. At least with if you're running it on the PC, you're usually running it through a shell, right? So once the program is done executing, the control is returned back to the shell, or the program itself returns into the shell, and you get like a return value as well, even if it's like implicit. But with a microcontroller, you're not really returning back to anything. So if the thing returns, then it's, or if the thing exits, then there's nothing there. Which would be something interesting to explore. Oh yeah, the reason I'm mentioning this is because I keep saying there's nothing there. Because there's nothing there, that's why you have to use this. Um, yeah, you have to mention this thing here. And I forgot how I was gonna connect this to panics. I think it was um, I think I was trying to connect it in the way that um, how how returning is handled a little differently in when you're running the program on an OS. I think also panics are handled a little bit differently, and generally, I believe the panics are gonna show up in your console, in your monitor. Oh, another thing I need to look into is whether when I do cargo run, what exactly does it is it mentioned somewhere here? Wait, I'm looking at the wrong thing. I need to come here, and let's also open up these. Okay, we are stuck. No, we're not stuck. Okay, let's open up cargo toml. Let's open up, actually, okay, there's a build rs as well. So let's open that up as well. And let's open this up as well. Okay, this is interesting. ESP does not match. Why does it say ESP does not? I believe I have the toolchain installed. Yeah, I should have the toolchain installed. I am missing something here. I'm definitely missing something here. You know what? If this doesn't work, it should throw an error. The code itself is not throwing an error anywhere. Hold on. Uh, yeah. I'm not seeing any errors in the code itself. So let's try doing cargo build, and for the sake of not heating up the CPU, I'll set it to jobs 2. Oh, there's the fan. There's the fan. Dude, hurry up. Hurry up and finish, because I don't want this thing to heat up. Did I do cargo build or run? I meant to do build. No such file in there. Oh, wait. Why did it go for this? No, yeah, it's supposed to go for this. Actually, it's supposed to go for this. It's supposed to go for this. However, so and so not found. I forgot in what situations I would be having this issue because I'm pretty sure I have the thing installed. Wait, let's do cargo install list, or I think it's rust up toolchain list. But is that gonna list the targets? I don't think that lists the targets. Okay, it says ESP. Yeah, no, I don't. How do I see how do I see where I installed the targets? Why is the fan? Okay. Uh okay. I like this. Linker be nice. Okay, in what situation? So this is the build. This is what would be giving me the error, right? This should be um hold on. Yeah, okay. So, I remember the target being named something else. Have have the target names changed? Because I believe they were named something else previously. I need to. Where are the targets mentioned? Not in Rust toolchain. Probably cargo toml. Um, is the target mentioned somewhere here? I don't think so. Yeah, wait, the target is not mentioned here. I needed the target to be mentioned. Should I create a brand new project? I guess wait, real quick, let's go one step back and then go into this and um what are we looking for? I guess let's open up the tool chain. Okay, that's still the same. Oh God, what did I mean to do there? No, I can attach to it again. But what did I mean to do here? Oh, um, that's what I meant to do. Okay, so here, let's go back. Let's go there. And is it cargo lock? Or was there Rust toolchain? No, cargo toml. Let's look at cargo toml. Dude, one of these places mentioned okay, my fans were going crazy because for some reason in the middle of what I'm doing right now, Ubuntu decided to pop up that updates thing. Sometimes when it has to do uh, whatever calculations it's doing to figure out, hey, so and so packages need to be updated, that's when the fans start to go crazy. So that's why all of a sudden I was having this issue. Now, okay, sorry, zoned out. Okay, where was the information, dude? See, I was mentioning this before. I was mentioning before how like someone like me who is still very much a beginner would also have these issues. Still very much a beginner, but not a complete beginner, would also have these issues. So then imagine what it's going to be like for someone who's like completely brand new to this. Now, I remember Target being mentioned. Um, I definitely remember Target being mentioned. It is not being it's not being shown here though. Okay, what if I try to update the tool chain? Um, um, okay, the active toolchain has been installed. It's active because overridden by so and so. Should I close this? Wait, no. What was the command to update? Okay, hold on. Toolchain update. If your Rust was built with the no self-update feature, it cannot update itself. This is not the default, and so on, so on, so on, so. Just Rust update? No, no, it's the toolchain that I need to update, not just. Okay, self-update, update a specific toolchain. Update Rust only. Okay, Rust update all toolchains. It's just Rust update. Okay, let's do that. Okay, let's see what all is being downloaded now. Okay, we have RISC-V. Again, RISC-V. I believe RISC-V got added to the stable toolchain. As in the target, um, RISC-V got added to the stable toolchain a while back. In fact, it was Extensa that wasn't added, or was it Extensa that got? No, it was RISC-V. It was RISC-V that got added. The reason I'm using Extensa specifically is because my specific version of ESP32 uses the Extensa architecture. It doesn't use RISC-V. Um, okay, removing. Okay, okay, okay. Okay, it's not updating the. How do we update the targets that are installed? I don't remember. Let me go into ESP32 Rust book, and I need to look into the installation of the tool chain itself, because for Extensa, I needed to download a separate tool. I remember that. Okay, tooling installation, tool chain installation. We install Rust. Okay. For there was something for Extensa devices. I was using ESP up. Okay. So with ESP up, uh, yeah, we're just waiting for this thing to finish up. I'm doing an update while streaming, dude. This is fortunately they're not like all that massive. In the meantime, I can probably look at Rust up, not Rust up, ESP up. So what ESP up installs? Okay, install all the necessary toolchains for all supported espressif targets by running so and so on Unix systems. Set up the environment variables. See the different methods in ESP up README. Windows users don't need to do this. Okay, ESP up installs the espressif Rust fork with support for espressif targets, stable toolchain with support for RISC-V targets, LLVM fork with support for extensor targets, and GCC toolchain that links the final binary. Does it mention extensor anywhere here? If it doesn't, I think I'll need to do ESP up install. Let's see if it updates. Previous installation of LLV. Wait, hold on. It found. Okay, installing so and so targets, installing GCC. Dude, I remember this download being done before. Okay, creating a symlink between so and so. All right. I also remember target being mentioned, I believe, in Rust toolchain, not in, well, oh, not in cargo. Okay, for extensor Rust toolchain. Okay, in the meantime, let me continue reading this. Environment variable setup. I believe I have done that. Yes, I'm pretty sure I've done that. Pretty sure I've done that in the past. And I think I had set the stuff manually. Oh, there was an update option to get started, set up so and so variables. Okay, okay. Now, let's try building this again. Oh God, why is it building everything from scratch? Give me a second here. Okay. Yeah, I probably shouldn't have done the building process. Holy shit, dude. This stream is not going the way that I thought it would. I think I'm gonna add in brackets scuff in the what do you call it? In the title. This is crazy. I should have done like at least a test build before I tried to stream this because I would have run into these issues. Okay, for details so and so. Okay, all right. Install sub command, extensor Rust destination path. Okay, okay, okay. So the last time it failed right at the linking stage. You're you're joking, dude. Failed again. Yeah. Okay. I am not sure what's going on here. We're gonna try update because it worked the last time, but the last time was like a while back. Let's try creating a new thing. Okay. What was I talking about? Oh, what was I doing actually? Hold on. I was previously in this one, so I'm gonna close this and then create a new thing. And we want to go into this learning ESP, ESP Proj 02. And now we want to try this. Hold on. Hold on. Wait. How is this working now? Was it just the environment variables that needed to be changed? What if I try to build from an existing shell? Uh, let's do it from here. ESP Proj 02 cargo build. It's not failing here. Okay, oh, am I still getting, yes, I'm still getting an error here. But yeah, I remember under toolchain or under cargo, one of these two, I had to specify the target. Or maybe that became unnecessary once I started using the TUI. I can't remember. There was like the workflow has been it's been updated over time and it's been updated for the better. but like I still kind of remember some of the older stuff. I should close this because this is the cargo file for the previous project. Yeah, okay. So I'm not sure how to. Well, I mean, if the thing is linking, I think we are good. I think we are good. What I can do is make a change to a string here. Just like add a space in there, or say something. Hold on, give this a second. I don't think I should run cargo build right now while this is doing its thing. Now I'll run it. Okay, that built perfectly fine. Am I editing the correct project? I think so, yeah, yeah. Um, Maybe let's make some change. Let's make a change to something in here. So let's say let a equals 5. Um, I don't know if that's going to get stripped away. Okay, it got compiled. It's giving an error, but it got compiled. Okay, okay. All right. Now I need to, what is this? This is not Blinky. I need to open up Blinky. Where is it? Examples. Yes, yes. And I believe I have enabled the unstable features, so we should be good. I could just like create a Blinky thing here. Oh, wait, no, I should close this. This is gonna load up. Hold on. I don't know what this is gonna end up pasting. Okay, so I'm just gonna trust this. Source, let's say examples. There's no examples. Uh, okay, wait. We'll modify the. Yeah, we'll just use this. We'll just use this. I need to paste this somewhere. Let's create a scratch one, and okay, right. So let's now close this, just in case if the Rust analyzer is like loading two separate projects and then it starts to eat up memory. I don't want to do that. Okay, right. So we are gonna bring this here, and we're gonna directly edit our main function. Let's take a look at everything that's going on here. I I don't think I need backtrace. I don't remember if I even enabled backtrace. Um, is everything else the same? Okay, we need ESP HAL delay GPIO level output config. uh, delay then GPIO level output and output config. Okay. Then what else is required? We need print line. Use ESP print line. Print line. I think the bootloader thing is done. Yes. Okay. Peripherals. Let's initialize that. Okay, that's been done over here. Is it the exact same? ESP HAL config default. Oh, there's a different thing going on here. Oh, it's probably for this stuff. Yeah, we're not gonna be using this. We are gonna be okay. So that's our config. This is returning. Oh, we need a loop so that it never exits. All right. Okay. Print line hello world. We can do that. I don't think. Yeah, I don't think we need this. We can do print line hello world. That's gonna print to our console. The peripherals have been initialized, or the peripherals variable has been initialized. Then we need mutable LED output new peripherals.gpio 07. In my case, what's the thing called? Hold on. I think minus 23 maybe, because I already have a bit of a circuit set up. It's of course not shown on stream because I don't have the webcam set up, but I do have a very simple LED circuit setup. Okay, output. Uh, Hold on. This thing is stuck. Okay. New, and then wait. What is it? Output new, peripheral, so and so, level low, default. Okay. Level low, I've typed the wrong thing. Level low, config. I think it's config options, or is it just config? No, I think it's config options. Output config. There you go. Output config, default. Okay. Wait, what's the issue here? Okay, so this takes a pin. Wait, this takes a pin. This uh wait, I didn't get it. So we have the output pin. Oh, I think yeah, it's not peripherals, it's peripherals.gpio. GPIO 23, I think I'd said. Yeah, I believe it was that. Okay, then we will set it to high. And okay, you know what? We'll start by doing that. Um, LED.set high. If this works, my LED, which is currently blinking, it should just go on and stay on. So let's run this. Oh, cargo run. Okay, so it does do the monitor thing. And that is the target that I was thinking about. Extensor, ESP32 none ELF. That's the target I was thinking about. Okay, so Hello World works. That's great. If I can get print line, whatever is printed out by print line, if it is going directly to STD out, then I might be able to pipe that to a named pipe and then have that be received elsewhere. Okay. Let's set up the delay thing. What was the... So delay equals delay. Did I add delay? I believe delay was one of the unstable features. Yeah, I think so. I think delay was one of the unstable features. Let delay new, and then loop LED toggle, delay milliseconds. Okay. Delay new, and then in the loop, LED dot toggle, delay milliseconds. Let's say, okay, let's say 200, just so there's a faster blinking going on. Yeah, dude, I'm kind of confused about, okay, so it's working, which is great, but I'm kind of confused about I'm kind of confused about, what was I saying? Yeah. I'm kind of confused about, wait, let's try printing this out. Okay, so this does launch ESP flash monitor, and this is doing the monitoring thing. So as many times as you are seeing those messages being printed, that is how many times the the blink is happening. Um, we could maybe change it a bit. We can say counter equals 0, and then LED has blinked these many times, and then counter, and here we do counter counter equals counter plus 1. Sorry, zoned out. Wait, what is this saying? Manual implementation of an assign wait, okay, so what are you suggesting? Oh, plus equals works. It's plus plus that doesn't work. Okay, my bad. Yeah, plus equals works. Is that the issue? Yeah, that was the issue. Because okay, the reason I did counter equals counter plus 1 is because I was remembering that there's something in Rust, or there's something in other languages that I cannot do in Rust, but I couldn't remember exactly what that was. It wasn't this. It was plus plus. So I can't do counter plus plus. That's not a thing in Rust. Rust prefers to be more explicit about the operation that you're trying to do. Um, and apparently the counter plus plus thing, it's also error prone, because um, you might end up in situations where you are using the value, and the moment you use the value, yeah, the moment you use the value, you you increment it. So this way you don't have to have two separate instructions, but then it can become kind of confusing. I've also seen situations where this was, I believe, in C# code. It was either in Momo's implementation of OSC for VR chat, or in Stella's original implementation of OSC for Unity in general. It was one of these two. I don't remember who had done that, but they were either incrementing or decrementing while using that variable as an index in an array. So and this was another thing that made it a little more confusing. You have the option to have this increment slash decrement operator after or before the variable name. So you get to then decide whether it's going to increment first and then you use the value, or you use the value and then it gets incremented. But yeah, anyways, so this is our example, and we got this working. I'm still confused about why I was getting those errors relating to, because the target is supposed to be extensa something something non-elf, which is what it is now. But previously, for some reason, I was doing GCC elf. I'm not sure why that is. Anyways, I mean, it's working now. I still need to study this entire tool chain much more, because I'm still like wrapping my head around how this entire thing is meant to be working, or how these multiple tools are working together. I think the best thing for me to do would be to have a conversation with Gemini about this. Give me a second here. Okay. All right. So, um, what else was I supposed to do? I'm still kind of confused about like what went wrong there. I shouldn't close this. Um, hold on. Let's hope that I still have access to those older errors. Oh, damn. That sucks. Yeah, I closed the other one and now I don't have access to those old errors. Something I could do is I could create a new project and just copy all of the code in there and run that. Yeah, yeah, I could do that. Let's hold on. Okay, so we're gonna go back and we can probably close this and now go back here. Oh, what did I just do? Oh, okay, yeah, that's fine. So, ESP generate. Wait, oh, is it like this? Yeah, it's ESP generate like this. ESP generate. Okay, then we select this and we'll call this ESP proj 03. Um, Give me a second here. Yeah, okay. So we want to enable this. We want to enable the unstable HAL features. We want to enable logging so we can print messages. DFMT, we don't need that just yet. We'll include the panic handler as well. Nothing is required from here, but here we need the NeoVim integration. I should find out exactly what this is doing. I believe I did at some point in the past. I had probably gone over, I'd gone through the ESP generate repo and I got GitHub Copilot to explain to me exactly what this option is doing. Okay, Rust toolchain. So this time or well, in the previous project that I had opened, I had enabled this. What if I don't enable this? Because I've found that I don't need to mention this. Though, I mean, yeah, hold on. Template default. Okay, so the template default might be ESP anyways. Okay, okay. All right. Um, yeah, I should find out what this is doing. Hold on. I can probably open up another conversation with Gemini. Not Gemini. GitHub Copilot. Okay, so we are looking for ESP generate. Generate. Okay, great. Okay, can you analyze this repo and tell me um, what exactly happens when I check the uh, optional editor integration. What exactly is it? Add settings for NeoVim. Add settings for NeoVim option in the ESP generate TUI. Also, what exactly? I mean, the other thing is, yeah, it's fine. Okay, I'll analyze the repo to understand so and so. Okay, okay. Template editor so and so. So it's doing its analysis now. Okay. When you enable the NeoVim option, a file named nvim.lua .nvim.lua is created in your project root. This is a NeoVim configuration file that configures the Rust analyzer for your ESP project. File contents. Wait, is that true? Hold on. We are gonna. I think we are done with this. Yeah, we are done. So we're gonna save this. Let the project be created. We need to cd into this, and let's open up the project in Yahtzee. Oh, that's interesting, dude. Okay, we can yeah, we'll open this up, and here we need to open up main and also .nvim.lua. I need to look into what the shortcut is to show hidden hidden files here, hidden files and directories. Um, okay. All right. Okay. Okay. This is what was popping up for me. And this is why I was getting that error previously. Yes. This is why I was getting that error. So now if I come here and cd and then go into this cargo build, let me not do this just yet until this is done. Um, yeah, let this finish doing its thing because otherwise my fans are gonna go crazy. Already all 4 of my cores are at like 100% while this is doing its building thing. Any moment now. Okay, all right, we are good. Now, oh, jobs. Okay, I want to see if this throws an error now or if it's fine. Okay, it's not throwing an error now. It's not throwing an error anymore. I'm confused about this. I mean, I'm not complaining though. I'm just confused about why I was getting an error before. And I'm not getting one now. The target is not being mentioned anywhere here. No, dude, there's something that I'm missing. Um, Let me come here and go into, actually, let me open up a new tab. Go back. Okay, here, let's show all the, there it is. There's the target. And yeah, there's the target. So it also mentioned, this is what I was talking about. Target would be mentioned. And yeah, in this case, it is being mentioned. I believe target gets set when, okay, I wanna confirm this. So it's extensor hyphen ESP32 hyphen none hyphen elf. Extensor hyphen ESP32 hyphen none hyphen elf. Did I forget something? No. Okay, I've noticed that in the um wait, Rust analyzer, so and so, target architecture, set the correct build target for your selected chip. It's placeholder, okay. I remember, oh, words, holy shit, what just happened? I remember there being a thing. My God, what just happened? I remember there being a thing where I I didn't specify. Actually, no, the thing that I'm talking about was I was confused about why it is that it selects extensor by default, which I wasn't complaining about. I was just curious about why it does that. Um, okay, Rust toolchain equals so and so for cargo operations and type checking. Okay, all right. Uh, I've noticed that in the TUI when I no, that in the generated project in the, what is it, cargo config? Yeah, in the dot cargo slash config dot toml file, target is set to extensor so and so. This is great because I'm targeting ESP32, which requires that target. But what I'm wondering is, how does the tool know that I want this target, despite me not specifying anything? Okay, now I can see the answer. Let me check what chip target method returns. Perfect, I found it, so and so, so and so. The tool uses ESP metadata crate, which is a dependency defined in so and so. Chip selection, okay, okay. Um, so this answer is a little different from, okay, no user input required. This is why you don't need to specify anything. The tool gets the chip, you select it. Oh, okay, yeah, based on the chip that I selected. So if it's chip.esp32, then it gets the target. Great, awesome. Okay, so now, Sorry, zoned out. Okay. So, um, what was I doing? Yeah. So now that I have this set up, and I'm still kind of confused about, oh, maybe I can get, oh, hold on. We need to do something here. We need to open up, um, we need to open up the other main. So come here and is main in here? No, there's bin, and then I keep forgetting this different folder structures thing that, oh god, okay, it's gonna start loading the entire thing now. Let's copy everything quick. Let's copy everything quick and just replace it. Okay, now let's delete that or close the buffer. Wait, something is off here. Oh yeah, no. We're good. We're good. I guess I just never deleted this, and so that's why something seemed off. Okay, now in cargo run, let me look at, because there's something for verbosity. Um, let's look up the word. Oh God, what are you doing? There, verbose. Okay, it's just V. There was a second V, very verbose. Okay, verbose slash build rs output. Okay, we're gonna do that. Okay, um, we are gonna do that first for build, and then we're gonna run. I don't know what's. That's a thing only for run, not for build. Okay, let's see. Let's see what we have for build. Yeah, this has. Oh, like that. Okay. Um, it's with a single hyphen. Wait, it's done. Oh, okay. I am gonna need to feed. This is crazy. Okay, I'm gonna need to feed this into. Oh, yeah. I could do that. Wait, let's pipe the output into build underscore or hyphen output dot, I don't know, txt. Okay, did that do what I wanted it to do? No, it did not. No, there's something, there's some specific things that I need to do in order to get like all of that output. Okay, it's running. Okay, what I'm seeing here, I'm seeing Rust C. So, yeah, I'm seeing Rust C here. So it is running this with a whole bunch of flags for various customizations. I can see the target being, oh, here. I can see the target being mentioned as well. Target is mentioned here, though. No, that's not the target. That's the target directory. This is the target right next to it. This is the target being mentioned. And this is the correct target. Dude, I can't seem to get over that other error that I was getting and why I was getting it, because I need to know why I was getting it, so that in the future, if I get it again, I'll know what's going on. To be fair, I don't fully. Oh, you know what I could do? Um, Wait, point this to, how do I point GitHub Pilot to this? Because there's a couple of things here. So this is running a bunch of things, right? Like, okay, if I clear and then do this, hold on, is this after my clear? Yeah, this is after the clear. Okay, so here, okay. Now, in here, this is calling cargo and passing a bunch of flags, which I didn't know you can specify. No, no, no. There's something else going on here. This is, it says running cargo equals so and so. Oh, these are all flags that are being specified. These are all, sorry, environment variables that are being specified. So these are then going to be used later on. We keep on going until, okay, cargo manifest path, okay. Compiler built-ins. Sorry, I'm just trying to read this entire thing. So far, I'm still just seeing environment variables until it eventually gets to this this point. So it runs build script build. Target equals so and so. Okay. And then it runs build script build. And that is apparently in target build so and so. Let's trace that if we can. Um, Target debug build. What was it? This one. And then it runs this. Now, how is this being built? Oh, I think this is being built in the other, like one of the above, one of these steps. In one of these steps, I think it's being built. Maybe it's part of compiler built-ins. I'm not sure. ESP so and so. The pre-calculated components change. Okay, compiling so and so, so and so, so and so. Okay, all right. So moving on, we then move on to, so these are all, again, wait, these are flags. So when there's flags, were there any flags here? There were no flags, but there are flags here. So when flags are involved, usually something is being called, right? Let's trace this back. Just says out directory, so and so. Oh, the flags here are for Rust C. So that's for the compiler, and that's the specific compiler in the ESP tool chain, the specific Rust compiler in the ESP tool chain, not one of the not like the stable tool chain. Okay, so that runs, and then I think all these flags are for, yeah, I think all these flags are for yeah, I think all of these flags are for Rust C. I'm not sure. Okay, then what's being run here? Are there flags here as well? Yes, flags start here as well. This is also for Rust C. There's a different set of things happening here, I guess. I need to, dude, I need to find a way to understand the build process. What exactly is going on in the build process? And I don't know. Oh, okay. I'm in ESP generate. Okay, now let's assume I have created the project. I'm assuming you will be knowing what the project structure would look like in this case. And then I type in some simple blinky LED code and then hit cargo build. Can you tell me everything that happens throughout the build process? Oh, let's assume I've created the project. Um, okay, selected ESP32 as the chip. And then, oh, wait, no, this should come over here. Let's assume I have selected ESP32 as the chip, created the project, and I have typed in some simple blinky LED code and then hit cargo build. Can you tell me what exactly happens throughout the build process? Because I feel like this build process is very different from an x86 underscore 64 binary build process, especially considering that I'm using the ESP toolchain, not the stable toolchain. Yeah, I'm wondering if ESP generate might have that information, because like maybe there's information about um, build related flags, and there's a build script as well that gets generated. There's a bunch of build related information, a bunch of build related instructions. So if this project is responsible for making those kinds of things, then I'm assuming that if um, one of these LLMs analyzes this repo, we're going to be able to learn what the build process looks like. Okay, perfect. Now I have information to give you a comprehensive answer. Let me explain the entire build process. The ESP32 build process deep dive. When you run cargo build on an ESP32 project generated by ESP Generate, here's everything that happens. Cargo initialization and toolchain detection. So first, cargo reads the config.toml file in .cargo and discovers the target triple extensor. Oh, that's what you mean by triple. Okay, because it's extensor, ESP32, none, and elf. I'm guessing that's why it's counting it as a triple. So like there's three of them. Okay, instead of your default x86 underscore 64 target, then compiler flags. Okay, for extensor chips, no standard setup files. Then build std core, compile core library for source from source for the extensor target. Then cargo applies the rust toolchain.toml and invokes the ESP toolchain, not stable. You have a custom Rust toolchain, which is ESP, installed that supports extensor ISA or instruction set architecture. This is fundamentally different from the standard stable toolchain. It has extensor architecture support built in. The compiler now knows how to emit extensor machine code instead of x86 underscore 64. All right. Then dependency resolution. Cargo resolves dependencies from cargo.toml, so ESP-HAL, ESP bootloader, ESP IDF, ESP printline, and so on. These crates are designed for no STD embedded systems and provide hardware-specific functionality. Then build script execution, build.rs. Cargo runs your build.rs script. This is crucial for embedded targets. Okay, what it does, it tells the linker which linker scripts to use. Linker scripts define memory layout, such as RAM, flash, etc. for the ESP32. Then link all.x, main memory layout script from ESP-HAL. dfmt.x is an optional debugging / logging layout and error handling script, extensor specific error recovery. Then core library compilation. Because of build std, dude, this is crazy. We're getting all of this information just by getting GitHub Copilot to analyze, or in this case specifically Claude Haiku to analyze the repo. This is insane, dude. Where was I? Because of build std core, Cargo compiles the Rust core library from source for the extensor target. The core lib contains fundamental types and traits such as option, result, vec, etc. Since extensor is not a standard supported platform by the stable toolchain, core must be recompiled. This is CPU intensive and why the first build takes longer. Okay, all right. Crate compilation. Your code and dependencies are compiled using the extensor compiler backend. Semantic analysis. The Rust compiler parses and type checks your code. LLVM IR. Oh, it's going through the entire compilation, like the multiple phases and stuff. Okay, LLVM IR generation. What is going on? Holy shit, dude. Rust code intermediate representation. LLVM extensor backend. IR to extensor machine code. Okay, okay. And then object file generation, machine code to object files. This is different from x86 because it has different calling conventions, different register allocation, different extensor specific optimizations, and different instruction encoding. Okay, all right. Then linking. The linker combines everything, your compiled code from main.rs, the compiled dependencies like ESP, HAL, etc., the standard library, and linker scripts that define memory layout. Okay, this produces an ELF file. This is not executable on your computer. It's in ELF format, but with extensor machine code inside. It contains all the debugging symbols. Then post-processing, which is optional, it generates flash images. No, generate flash images. If using ESP Flash or ESP Tool, the ELF is converted to binary images that can be flashed to the ESP32, bootloader, image, partition table, app image, etc. Okay, this happens automatically if you run cargo run with the proper runner configured. Okay, you know what? Yeah, I'm gonna continue reading this, but I do want to say my curiosity has been satisfied for how things are working on a lower level here. And I think I'm more or less caught up on the basics of setting up the project and running it. Something I would like to look into is what would happen if hold on, hold on. I'm going to do something here. Um, I don't want to run. Hold on. Okay, so we're gonna come here. We're gonna close this. Uh, do this. Um, ESP generate. Okay. ESP generate. Sorry, I'm just dealing with a bit of lag issue here. Okay, now we should be good. Okay, ESP generate, ESP32. This is going to be ESP proj 04. Okay, enable this. Um, enable this. Enable that. Don't need that. What if I don't enable this? What's going to happen? Actually, okay, we don't need to open up NeoVim. I just like I'm glad that I thought about this. But yeah, we don't need to open up NeoVim. So we're gonna do this. Oh, you know when we can do this? We'll do this when I'm actually gonna open the project up in NeoVim. For now, we are not gonna check this option. Okay. Um, everything else is fine. We're gonna save this. And now in here, what I'm gonna do is come over here, source bin yank, and then come here. Let's go back to the specific thing. We need to go to 04. Okay, delete this, paste that. Hopefully it's the right one. Yes, it's the right one. Okay, so now we can, oh, another thing we can do is okay, it added the thing by default, so we are good there. What does the NeoVim thing add? Rust analyzer dot cargo extra environment. Okay. Oh, this might be yeah, I need this. I need this. I need this, otherwise ESP32 Rust specific Rust analyzer behavior is probably not going to work well. So I need this. Okay, all right. I guess we can just compile the project now. Go back, ESP04, and build. Oh, it's gonna build everything from scratch? No, it caches stuff, right? I've done this build multiple times now. It caches stuff. So a bunch of the other stuff is done already, hopefully, I think. No, maybe not. I don't think it's cached. Um, maybe the other stuff is cached. I'm not sure. I don't think that's cached either. It's building everything from scratch. Okay. 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 I'm glad that I mentioned the flag, the jobs flag, because otherwise I would be having a serious problem. Give me a second here. Okay. All right. Okay, now is there a way for me to open up the file without NeoVim just completely freaking out? Let's cd into this because I just need to change like one number there. Literally all I need to do is change a number. So let's do src bin main.rs, open just that. Oh God, okay, it's loading everything up. Let's make the change quick and yeah, okay, done. What if I, okay, let's make this verbose as well. Okay, it is flashing and done. Okay, all right, cool. Oh, okay. You know what? I think we made some good progress today. And I think this is a good place to end off on. I'm going to continue doing this research and maybe set up like a couple of simple circuits. I do want to get a proper understanding of the build, or I don't know. I feel like I need to sit down and think about this and just be like, oh yeah, okay, this is what's happening. And then once I feel like I've wrapped my head around the building situation and how exactly you're supposed to be setting up a project and working on these projects, um, then I'll do a couple of these test circuits to see how. Oh yeah. After this, I need to do the named pipe thing. I just remembered that, dude. I need to do the named pipe thing. I need to pipe the output of whatever is going on here into another program and see what that looks like. Yes, absolutely. I need to see what that looks like. Is okay. No, no. You know what? I was about to do something just now, but like no, no. I'll do that after I've ended the stream. Um, give me a second here. Okay, so there's a bunch of people in this category who are doing a bunch of interesting stuff. Uh, hold on. Oh, cannot go here anyways. So we are just gonna go to another. Okay, I've got two others that I'm gonna check out. Okay, I don't know what's going on here, but this person seems to be doing a cooking stream. Sorry, I'm still like looking. Okay, you know what? Yeah, we're gonna go. We cannot go. Oh, oh, yo, okay, Omar is streaming. We have rated Omar in the past. Omar is pretty chill. Um, Omar is currently doing some Arduino stuff. So we're gonna drop a raid on Omar. Okay, buddy Omar. Yeah, we're gonna that's gonna be it for today's stream. We're gonna go raid Omar and hang out in their stream. Um, Today was kind of productive. It ended up going in a direction that I wasn't really aiming. I was hoping for it to be quick and like I'll immediately set up the project and we can like focus on like the actual, Rust coding. But then we got stuck with build stuff. I guess my tool chain was out of date, and so uh, I had to update everything, and then Though, okay, the interesting thing is after I updated the toolchain, after that the problems went away. The problems got solved, which is kind of interesting. Um, and also good because that tells me that it's going to be a lot more frictionless from now on. That being said, I do wanna start working on more and more projects in this, and I think the best way to go about it would be to immediately start with the Arduino projects, the Arduino examples. Okay, okay, my time is running out. That's gonna be it for today. I hope you guys have a nice day, and I'll see you all next time. Peace.